Hello again. So we have discussed the single point calibration in the previous video. So today in part 3 we will continue about the calibration, which is a 2-point calibration. And also we will continue with the rest range of the voltages that we measure using the Arduino.
Okay, so we reached to the 2 points calibration method. So again, from the name, it's a 2 points. So we will have 2 points to calibrate because if you remember in the first part where we have a single point, mostly the raw data, it will be adjusted in a linear manner, or what they call is the same, okay, not linear, sorry, because it is linear, but in the same offset. Okay, for example, this is our reference in the blue. So previously, if you remember, so let's say this is uncalibrated data, so it will be, all of it will be go down or go up in a constant factor. But we notice that at the low end and the high end, the value or the accuracy was out. And in the middle range, the accuracy was acceptable. So in this case, we can use a 1-point calibration. We need to go to the 2 points. 2 points, it will take a high level or the high value measurements and the low value measurements. Then it will find the reference or the factors that need to be adjusted. Then it will adjust the raw value accordingly. Okay, according to our reference. With our reference in this example is the DMM. Sorry, not easy to do down. Yeah, so it's the DMM, and this one is the ADC voltage. Okay, so yeah, we notice something like this. So this one will be more accurate to find the factors that calibrate our signal. Okay, so now we came to the 2 points calibration implementation. Okay, so for the 2-point calibration, what we want to do, let me drop the equation first. So these all talk about the single point. Here I'll talk about the 2 points calibration. So what I want to do, let me copy paste the equation for you guys to save the time. So here we go. The corrected value or the calibrated value, it will be equal to the raw value minus the low, the low point of the raw value, okay, multiplied by the reference range, which the reference range we can calculate it by the delta of the high and low of the reference divided by the raw range. Raw range again is the high and low of the raw plus the reference low. Okay, so this is the equation we will use to calculate or calibrate the 2 points of our data. Usually I would use the map to do the 2 points calibration. Map function is very famous in the Arduino compiler, but the one issue, which is a very big fat issue, is that the map, it works only on the integers. It won't return any fractions, won't return any decimal point in calculation. And also, since we have a decimal point, so map doesn't work for us. So what I did, I developed a function which is almost similar. I can say it's similar like the map, but I tweak it a bit. I call it 2-point map. Okay, where all the parameters, they are floats. Okay, we have the x, which is our data. We have the what they call the minimum, and the in minimum, the in maximum, and also the out minimum, out maximum, which is that I can say like this is the from, and this is to, and this is the data that we are working on. And again, this is exactly exactly matched to our equation here, okay, where we have the raw range and the rest of the variables. Okay, before I use this, I want to know my 2 points values. Okay, this is one thing. Another thing, I won't use the voltage anymore in my my calculation. I will use the ADC, the raw ADC value, so I don't need this anymore. Okay, so I don't want this. Let me comment this, and from here I will print the sensor value, the ADC value directly. So here I will print this guy here. So let me, so this one will be still as a single point calibration output. So I will copy it. This is test for the second, or what they call 2 points. Okay. So pair, so we have sensor value, print out. I want print out directly. So what I want to see, let's say, at let's say 1 volt. Then I want to see the ADC equal to what? And at 5 volts, the ADC equal what? So I want to get this data. Okay. So yeah. So that's why I set the ADC value, which is the sensor directly from the analog read. I mean the data from the analog. Okay. So I'm updating now. Oh, got issue here. Why? Voltage was not declared in the scope. Oh yeah, because I uncomment this thing. So okay, this one also I don't want. Okay, go. Yeah, because the voltage I declared here, then I take it out, so it looks really okay. No problem. I take out the whole thing. I don't need it anymore. What else? Sensor value was not declared in the scope. Why? It's here. Okay, no problem. I don't want this either. This guy and this guy either should be. Oh, because consider out of the loop. No problem. We take out. Now, hopefully the compiler will be happy. Yep, it's uploading and done. Here we go. So now I want my data. Here we go. So now let's go back to our page. I want to start with 1 volt. So let me go down to 1 volt. Go down to 1 volt. Almost there. 1 point. Slowly moving it. Almost there. Not easy. Okay, 1 volt, almost a bit. Done. One volt. Okay, so at 1 volt, the ADC is about, let's say 210. About 210, yeah. Now we go to the 5 volt, and let's see what should be our ADC. 2, 3, 4. Almost there. No, too much. Yep. So at 5 volt is 1023 exactly. So 1023. Here we go. So now we have these 2 parameters, so I can enter it to my equation. Okay, so again, I will have what I have to do. Okay, I will declare the float. Let's see here. Float voltage. The voltage will be equal to 2 points Yeah, 2-point map. So the first one will be my data, which is the sensor value. Okay, this is the one that I want to map it. Now I want it to be from 210, okay, enter 1023. This is the minimum and maximum. 2, I want to convert to 1 volt, 1.0, 1.0 enough, enter 5.0 volt, 5.0 volt. Okay, that's it. So now I copy this guy, this is my output, and I just bring to the serial. Let's see. Oh yeah, it's expecting a semicolon. Sorry, my bad. This thing you don't need. Okay, let's do it. Compiling, looks happy, uploading. Done, good. Here we go. Oh, sorry, why here 5.2? Should be 5.0. No wonder I see 5.2. Oopsie. So yeah, I need to upload again. Now we should 5 spot on data. That's good. So we can see here 5 volt and the output is and the reading is 5 volt. Perfect. So now I'll try to modify it. I'll bring it down 4.9, 4.8. You see guys how it's very match and accurate because we have the 2 points calibration. Okay, we go down to 4 volt, 4.02, 4.0234. Whoa, nice, because we expect a lot of noise from here. It's not that good set up because we use breadboard and a lot of these lousy wires, but it's acceptable for the POC purpose or proof of concept. Here we go, 3.7. Like go down to 3.24. Voila. It looks really nice and acceptable. Let's go. If you see lower than this, here we go. Nice. Nice. I'm happy with the result, guys. You see how accurate it is. Now you can get like very high in milli or micro resolution of our voltmeter. Here we go. So yeah, we have learned how to do the single point or 1 point calibration, 2 point calibrations, which looks cool and fantastic. We can get a very good result out of it. So now we can just put a voltage divider to improve or increase our range. Now our range from 0 to 5, we can add a voltage divider to can go up to 12 or 24 volts. Okay, let's move on. Okay guys, so from here, let me zoom in a bit. If you remember, back then we were talk about if is the range or the power supply range, okay, that we want to measure is from 0. Sorry, let me take pen. Yes, if it's 0 to 5 volt, we can directly supply it to the ADC, and this is what we did so far. So now we will try to measure the voltage of more than 5 volt, which is 0 to 12 volt. So since we want to measure more than 5 volt, so we need to have what called voltage divider. So same as we explained at the earlier of this video, that we need a voltage divider. So now what I will do is, since we have our new power supply, this is go to the ground, should be ground here, and this one go to our voltage divider. Okay, ground also. Then we take from this point our input to the ADC. Okay, So since my power supply will be from 0 to 12 volts, so the voltage divider will be the R1. Here is the R1 equal to 30K ohm, and the R2 equal to 18 kilo ohm. Okay, so now with these resistors, the maximum of 12 volts will be converted to 0 to about 4.5 volts. Okay, then this measurement or this value is okay for the ADC. It's safe for the ADC to be measured. Okay, guys, so I will use this voltage divider now to measure the higher voltage, which is from 0 to 12 volt.
Okay, so let me zoom forward to show you the voltage divider I'm using for the 12 volt. Okay, so here I'm using these two resistors here. This one is the R1 that connected to the VCC or to the input from the source that we're going to measure, which is 30K. Okay, this is 30K. And the other one, which is connected to the ground, and this one is 18K ohm. Okay, so this is my voltage divider here. Okay, let me zoom back. So now let's drive the code for this 12 volt measurements. So again, I will start with the analog read serial, okay, as an example. Same what we did for the 5 volts. Okay, so here we already take the analog reading from the ADC. So I'll change this to float so I can see the floats points. Yeah. Okay, so here I will define my voltage that will be convert the ADC reading from here into a voltage. Okay, so again, float voltage, let's say 12 volt, equal to the sensor value. Okay, I will multiply by 12 volt. This is the maximum value I'm measuring it, and I divide it by the resolution, which is the 1023.00. Okay, this one also, let's make it 0.00. Actually, this one shouldn't be 12, should be more, but let's see why later. Okay, then later when I want to print, I'll just print the voltage. Yep, voltage 12 and add delay, let's say 100. Okay, let's upload and see. COM11, correct, Arduino Uno, let's go. Okay, uploading, looks nice and done, cool. There we go. So you see the measurement here is about 1.9. Okay, although if you notice here, the multimeter is reading the voltage, the input voltage, okay? This is the input voltage to the ADC. So now I will try to change it, to change the voltage. Okay, let me increase the voltage. There we go. You see it's increasing, but it's not matched. Like I'm supplying 3.1 volt, but the ADC gave me, and also from my equation gave me 2.8 only. Okay, so now why we got this different is because the issue is here due to the voltage divider of, let's say, oh sorry, I have 30K and also we have 18K. So if you do the calculation for the voltage divider, the V out, okay, that's going to the ADC will be equal 4.5, actually, not 5. Okay, so the V out will be equal 4.5. This one, when the V in is equal to 12 volts, okay, so the V out is 4.5. So I already check and measure. If I want to make this to be 5, so I need to input about 13.3. okay, so the V in should be 13.3. so it means this one, it should be 13.3. okay, now the measurements will be accurate or almost near to the accurate. So it's required very small amount of calibration, then it will be okay. So the calibration factor will be too small. Okay, so let's see. Here we go. Here we go. You see now, I'm supplying 3.1 and I get about 3.1. Voila, it's done. So yeah, this one actually I measure it after I increase. I mean, how I get this number, if you are curious to know, I just make sure that the input, oops, it's giving me a warning, but it's okay. So I just measure the input and the output of the voltage divider. Then when I monitor the output, then I increase the input. When I increase the input until about 13.3, this one give me 5 volts, so that's why I choose the 13.3. okay, so now I'll try to change my input. Let's say now 3.3, here we go, sorry, 3.3 at 3.4. if I go more, you see now 4 volt, that's good. Actually this one should go all the way to 12 volts. It's safe because I already have the voltage divider. Okay, this is 9, 5 something, here we go. You see now I'm supplying 5.4, 5.4 something, or almost 5.5, that's good, that's good. If I go up, oops, ups, okay, my voltmeter gone. There we go, come again. So yeah, now 7 volts. I will go up more. I can go maximum 12 volts. Here we go, now I reach 9. Let me go up more, 10, 11. There we go, until like 11.3 is match, exactly match. It's very small amount of difference. Okay, so now we reach to 11. Let's say 9. I don't want to go more than this. I don't want to risk my ADC. So here we go. So this is the maximum we can go with this voltage divider. You can see now we improve the range of the ADC so it can accept more than 5 volts. So now it can even give 12 volts. Now let's go down. There we go. Let's go, let's say 11, 11.09 or 1, that's cool. Okay, that's good. Let's go all the way to, like, say 7. So yeah, this is how we like now increase or improve the measurements of the ADC. Instead of it's limited only to 5 volts, now we can put more than 5, let's say 12 volts. Okay, so this is how it works if we want to increase the input more than 5. Okay, so let's say now I increase it to 12 volts. So later I will teach you guys how to even increase it more than 12 volts. Okay guys, so here we reached to the last part of our video, which is the 24 volt DC measurements. Okay, so here I designed the voltage divider. This voltage divider consists of R1, which is about 30 kilo ohm, and R2 is 8 kilo ohm. So if you do the calculation, the V out of this voltage divider will be around 5 volts when we
supplying 24 volts. Okay, so this one will converting 24 volt into a 5 volt. So if you see here, I'm injecting now this by the way, this meter will measure the input voltage. This one will measure the output. So you see now the input is about 12 volt, which is half of 24, and the output is 2.56. Okay, so now let's develop the code for this. Again, exactly the same. We will start with the analog read serial code. Then we will write our example. So again, first we need to have initiate or declare a new variable. Okay, so for example here I will declare my voltage, which is float voltage equal to sensor value, okay, multiply by this. By first it's the maximum input voltage, which is 24.00 volt, divided by the resolution, which is 1023.00. Okay, and for sure we shouldn't forget that this guy here should be float as well, so you can get a float values from my output. Okay, so now we just need to bring the voltage, and let's give a delay, let's say of say 100. Okay, we go to Arduino Uno on COM11 and let's go. Okay, it's compiling, that's good, and uploading, done, that's good. So let's open the cell monitor. So now we should see the voltage. Here we go. So now you can see here, guys, we are putting about 11.9 volt, but the reading is 12.4, which is close to it, but not that close enough. So that's why we need to apply the calibration as the one we learned previously. So now I'll try to change the input voltage. Okay, there we go. You see now I'm injecting 7.5 and the reading about 7.7 or 7.8, which is good enough. So now let me change it again. Here we go, I'm going down to about 2.7, and here we go, our reading is about 2.9. That's good. Now let's go up all the way close to 24. Here we go, it's 8, 9, 10, 14, almost there. There we go. So now I'm supplying 19.3 and the output is about 20 volt, which is considered okay. We just need to apply the calibration process. Here we go. So now we're injecting 22.5 and the output is 23.6. So it's kind of with the offset getting bigger now, which is again, we need to resolve this issue by calibration, or 2 points calibration to be exact. Okay guys, so this is the code how we managed to read the 24 volt DC volt using a voltage divider. Well guys, so here we reached to the end of the video. I hope it's not that long. So yeah, so let's conclude our video. Let me select the pen. Okay, let's see, it's the red color. So yeah, what we've been talking about is DC voltage measurements. Okay, we
we try to measure, and we already measured different ranges, start from 0 to 5, then 0 to 12, and 0 to 24. There's about 3 ranges that you can find in any basic multimeter. Okay, so now let's try to develop or complete the whole picture of our DC voltage multimeter or DC voltage meter. Okay, so let's say here we have our battery connected to the ground, and here is the positive lead that we want to measure it. Let's say we have our multimeter, so here is the input banana, okay, and here is the comb. Let me draw the comb in another color. Can I change the color? I can't. Okay, let's choose this color, for example. So this is the comb. Okay, so usually the comb will be connected to the ground. Okay, and this one, let's change the color, will be connected to the place where we want to measure. Okay, so internally we have, let's say this is for sure, this one is considered our multimeter here. Okay, here is the LCD, and then we have the selector. Okay, this is our selector. It looks like multimeter. So what do we have inside? I mean, inside the multimeter here is like this. The banana, okay, this banana will be connected to something like this. Either will go continue, let's say if 0 to 5 volts will be go straight directly to the ADC of the MCU. Then we have another voltage divider, go to the ground. Okay, then here we have another voltage divider, go to the ground for another range. Okay, so now what do we have? We have 1 point here, 1 point here, and 1 point here. Okay, so we have these 3 points. This point will give me a range that I can measure, let's say, from 0 to 5 volts. Okay, the first voltage divider will give me up to 12 volts. The second one will give me 24 volts. Depends on R1 and R2 calculation, the one we did just now. Okay, so now we have these wires. Let's say we have wire 1, wire 2, and here is wire 3. So inside the MCU, or inside the multimeter, we got MCU. And here is our friend ADC. So the ADC will be toggled or selected or connected to one of these following the position of the multimeter switch or multimeter selector. Okay, so when you select, for example, 5 volt range, actually the ADC will be connected to the first position. Okay, like this. And if, let's say, you connect it to, let's say there's 12 volt range, actually this guy will be connected to the 12 volt range. Okay, when you rotate this rotate it from 5 to 12 volts, or even go to 24 volts. Okay, so it means this guy will be connected to here. Okay, and etc. So this is how the multimeter will be changing the range and have different ranges. Okay, for sure this is very basic. We need some more protection circuits and all the other miscellaneous circuits that we need to add it to make sure to protect our MCU, protect our ADC, and protect the multimeter overall.
So yeah, with this we have learned how to measure the DC voltage, and we have learned how the internal of the multimeter working. Okay, and also we have developed like few voltage dividers that give us different range, and also the most important thing is we learn the 2 points calibration. Actually both, if I'm not mistaken, we discussed both the single point and 2 points calibration for sure. Since we have resistors here as our sensors, so the output might not be exactly same as our, what we intend to see. Okay, so for example, we are expecting this, but we are getting the red one. Okay, so that's why we need to take, at least for me, I prefer the 2 points calibrations, okay, to calculate the offset of this graph. Then we can correct the readings to the expected one. Yeah, so this is the most important thing. So every reading or every points need to be calibrated. Okay, so for example, if you have the direct one or the what we call, the 5 volt range, 12 volt, or even 24 volt, all of them need to be calibrated to guarantee the functionality of our device. Okay guys, so we have reached the end of our video. I hope you have learned something from this video. Don't forget to leave me a comment and give me your opinion about the video. I hope it's not too long for you guys. Happy learning, and see you in the next video.